ओके, सो इवन दो जेई मेंस हो चुकी है, मैं वापस ये सीरीज कर रहा हूँ, मतलब थोड़ा प्रैक्टिस में होगा उतना ही. नेक्स्ट 31st क्वेश्चन. 31st is the question of thermal expansion of a rod is temperature dependent and given by the formula alpha equal to AT, where A is a constant and T is temperature in T Celsius. Okay. If the length of the rod is L at temperature 0 degrees Celsius, then the temperature at which the length will be 2L. Seriously? Okay, so like 2 is equal to 1 plus alpha T, right? Oh, okay, this is kind of different because unfortunately you directly answer it's not linear anymore. Okay, so what was the equation once again? That dl upon L, right? This thing is equal to, yeah, what was the thing? This was the thing, right? Yeah, it's equal to alpha times dt, d capital D actually. So तुम्हारा temperature थोड़ा सा increase हुआ, then yeah, तुम्हारी चल रही रहेगी. Yeah, it should increase like this. That's the thing. And in this case, जो alpha that is equal to A times temperature. Oh, and unfortunately जो T है that's in degree Celsius, but it doesn't matter because GT in Kelvin Celsius दोनों same ही रहेगा. So yeah, T is in Celsius. Cool. ठीक है ना फिर. So you got like natural log of L upon L naught. That's equal to A alpha. Okay, AT dt whatever. So A T squared upon 2, right? And L naught मतलब जो 0 डिग्री सेल्सियस पे रहा होगा वो. Okay. So क्या बोला है? 0 डिग्री सेल्सियस में लेंथ क्या है? L है इसकी. Okay, so L naught fine. Then at temperature, okay, जब 2L हो जाएगी, so यहाँ पे 2L naught डाल दो. So like natural log of 2 is equal to AT squared upon 2. What does that mean? T is just equal to square root of 2 natural log of 2 upon A, or you can just say square root of natural log 4 upon A, right? Which is B option. Next question. Next 32. 32 is the temperature of black bodies increased by 1 degree Celsius. The amount of radiation emitted by it is increased. So it's sigma T power 4. That's the power. And amount of it, okay, whatever. Amount matlab kya? Energy, right? Yeah, the power. So sigma T power 4. So it's like 4 delta T upon T, right? That much. So like, okay, 4% increase. So C. Next question. 33. The volume of 0.5 kg of liquid water over temperature range from 0 to 50 fits reasonably well to the polynomial function V is equal to. अच्छा, तो volume दी है and in terms of temperature, where V is measured in cubic meters and T is okay in degrees Celsius, whatever. The volume expansion coefficient for liquid at 20 degrees. Once again, what is it? It's like dV upon V is equal to gamma dt, right? So gamma is just dV upon dt, and that times 1 upon V, right? Yeah. So what is dV upon dt? It's just equal to 2t times, okay, 2 तो है ही, तो वो 10 बाहर जाएगा. This is 10 power negative 5 times t minus 4 times 10 power negative 5. Okay. All of that upon the volume itself. So अपने को कहाँ पे चाहिए? At 20 degree Celsius. ठीक है, अपन वॉल्यूम को ढूंढ लेंगे, no big deal. So yeah, at 20 degrees Celsius you're saying. So ये 20 रहेगा. Okay, so 4 times 10 power negative 5 times 2 times 10 power 1. So this is like 8 times 10 power negative 3. अच्छा ठीक है, इतना भी, sorry, 8 times 10 power negative 4, right? Which is okay, it's very small actually. So it's small. और अपने को yeah, काफी बड़ा difference है इन सब में. So you know, you can just kind of ignore these guys. So ये क्या हो जाएगा? 4 times 10 power 2, तो ये हो जाएगा like 20 times 10 power negative 4. So 2 times 10 power negative 3, that is okay, so 0.02, whatever, still काफी छोटा है इससे. So 10 power negative 1 से 10 power negative 3 काफी छोटा है. So we'll just ignore these guys. V is approximately 0.5, so it's like 1 upon 2. मतलब ये हो जाएगा, तो ऊपर गया, it's just 2 times 10 power negative 5 times T minus 4, right? And what's T? 20 degrees Celsius is like 16 is the thing. So it's 32 times 10 power negative 5, or you can say 3.2 times 10 power negative 4. So मैंने यहाँ पे 5, whatever. Which is which options? B option. Okay, next question. 34. 34 करो चलो. Slow तो नहीं जा रहा हूँ, क्या पता. Centigrade and Fahrenheit thermometers are dipped in boiling water. The water temperature is lowered until the Fahrenheit thermometer registers 140 degrees Celsius. Okay, boiling water, फिर water temperature lower किया. what is fall in temperature as suggested by the centigrade thermometer? So boiling water, right? So boiling यानी कि 220 no 210 degree Fahrenheit. Yeah. So 210. Okay. You know the thing. 210 degree Fahrenheit. That is boiling, and 32 degree Fahrenheit. What? No, not 210. It's 212. Sorry. Yeah, and 32 degree is right. So of course. Okay. तो क्या हो रहा है? It's going from 212 to what? To 140, and 30 degree is, sorry, 32 degree is what corresponds to 0, and सेंटीग्रेड स्केल पे क्या हो रहा है? 100 तो कुछ तो भी जा रहा है ये x डिग्री, एंड दिस इज सपोज टू बी 0 डिग्री जब ये 32 डिग्री होता है. सो सब्ट्रैक्ट 32 डिग्री ऑन ऑल ऑफ दीज गाइस. तो ये क्या हो जाएगा? 180 डिग्री से गया, दिस इज गोना बी 0 डिग्री, और ये हो जाएगा लाइक -8 एंड देन 108 whatever, right? So it's 108 upon 180 of 100. That is the Celsius scale का टेम्परेचर. ठीक है. फिर तो ये कितना हो सकता है? तुमने क्या दिया इसमें? अच्छा, रजिस्टर. ओह गॉड, ये बहुत घटिया सा कुछ तो भी है. वॉट एवर. ये हो जाएगा 5/9 times 108. 108 is like 12 times 9, right? So 1 and then of course. So 5 times 12 is 60. There we go. Right, 60 degrees Celsius, which is B. Next question. 35. 35 is at 40 degrees Celsius resistance of platinum is this thing, and at 400 degrees Celsius it is this thing. Its temperature coefficient is, wait, what? Temperature okay, so the resistance or temperature coefficient, of course. So the resistance is given by, actually I should say resistivity, but क्या फर्क पड़ रहा है? Because same dimensions, right? Actually नहीं, not the same dimensions unfortunately. It's temperature coefficient, but temperature coefficient of what? Of resistance or of resistivity? Something per degree Celsius. Yeah, right. I think resistance का ही बोल रहे हैं, not anything else. Well, whatever. So 40 degrees Celsius, or is it something? I don't know यार. ठीक है. 314 है, उसके बाद में 3.76 हो गया at 100 degrees Celsius. So कितना 60 का change हुआ, and then yes, like 0.76 minus 0.14, which is 0.62, right? So 0.62, these many ohms change हुआ upon original जो था. Original was just 3.14. Isn't that like almost 5? Whatever. And all of this upon, so ये सब upon delta T, which is 60, approximately this much. तो ये approximately ऐसा रख सकता हूँ मैं, मतलब ये, you know, like this thing. So it's 6.2 upon 31, which is 0.1. So 0.1 upon 60. Yeah, 0.1 upon 60. That is the thing. So करो उसको calculate. तो ये ऊपर से it's like 10 power negative 2, which is, you can add is 10 power negative 3, and then you got 10 upon 6. So it's 1.4 degree, 36 degrees, so 1.66 whatever, 1.67 approximately times 10 power negative 3, which is, so यहाँ पे है ही नहीं. Oh god. But it clearly went from 40 to 100. So ऐसा क्यों होगा? 0.379. What? No. How can that be? Oh, ये 2 चाहिए यहाँ पे, sorry. It's not 0.1, it's actually 2 over there. So it should actually be 20 upon 6. Or yeah, basically like 10 upon 3. Let's go. This is going to be 3.333. So yeah, almost 3.33, whatever. Times 10 power negative 3. So where is that? That's 10 power negative 1. We don't want this. Okay. 2 times 10 power negative 2 upon 6, like 1/3 times 10 power negative 2. So that's really just 3 point. Okay, that times 10 power negative 3, which is this thing, of course. So almost that thing. It is 3.7. हाँ ठीक है ना, times 10 power negative. Makes sense. So A is the thing. Next question. I know मेरा काफी ऑफ था. एक्चुअल में ऐसा बिल्कुल नहीं है. मतलब अलग आया मेरा जो भी आया. But whatever. Approximate करो. Find the solution. 36. 22 gram of CO2 at, so 22 grams of CO2, that's like half a mole of CO2 at 27 degrees. So N is just 0.5 or 1.2 or whatever. Temperature is 300 Kelvin mixed with 16 grams of O2. So this is N1 बोल दो इसको, and what's N2? 16 grams of O2. So इसको थोड़ा सा अच्छी तरह से लिखते हैं. N2 कितना है? So 1 O2 कितना होता है? 32. Like once again half. Okay, at 37 degrees Celsius दोनों का same 37. Okay, so T1 is this thing and T2 is 310, whatever. The temperature of the given, okay, of the mixture is, right, so sorry, क्या energy तुम्हारी same करनी है बस, like okay, N1 R T1, okay, and then what, ये मैं पूरा क्यों कर रहा, I know how it's supposed to be, right? Yeah. Right, okay, wait a second, it's CO2 and that thing is O2. CO2 is linear, this thing is also linear actually. So yeah, मतलब उनकी degrees of freedom same हो जाएगा, right? Because it's a linear triatomic, of course. So same degrees of freedom, and then you can just do it without hesitation. So N1 T1 plus N2 T2 upon N1 plus N2. That's the final thing. So you know T1 और T2 दोनों में 300 का factor है, बाहर निकाल लो. 300 plus, so T1 के लिए 0, T2 के लिए कितना? 10. So like half times 10 upon, taking a 1, whatever, it's just going to be 5. So you know 305, I think, these many kelvins, which, right, okay, so that's 27 plus, सही तो कर रहा हूँ मैं. Yeah, मतलब ये 27 और 37, right? So 10 का 5 is 32, right? So A is the thing. Next question. 37. मैं बहुत स्लो कर रहा हूँ, ऐसा लग रहा है मुझे. 37 is a calorimeter of mass something, a specific heat something, contains 0.5 kg of liquid of specific heat something. Okay, mass कितना दिया है? 0.2. इसको कैपिटल M बोल देते हैं, whatever. Specific heat, okay, that's C, that's equal to 900 SI units full. Contains 0.5 kg of liquid, इसमें small m बोल रहा हूँ, so 0.5. और स्पेसिफिक हीट, इसको मैं कैपिटल सी बोल दूँ, क्या क्या फर्क पड़ रहा है? वो हीट कैपेसिटी यूज होता है, बट वॉट एवर. इसकी स्पेसिफिक हीट कितनी है? 2400 kg का, हाँ ठीक है ना, सब सही है, राइट. Its temperature falls from 60 to 55 degrees Celsius in 1 minute. Rate of cooling is, contains this much of liquid. Okay, तो दोनों क्या इक्विलिब्रियम में है कि नहीं है? We want the rate of cooling, so of course energy per unit time, right? Okay, no big deal. इसका तुम total heat capacity निकाल लो. So it is yeah, this time कितना, 18 and then 180. इसका combine होके बनेगा 180 and इसका combine होके क्या बनेगा? 1200. Something's off. Oh, it's just 12. Wait, no, it is 1200 actually. और इसका, yeah, it is 180. Wow, that's not good. Right. How did that happen? I don't know. But लग तो ऐसा ही रहा है. It's just 12. Of course. It's like 0.5 kg. That's 2.2 kg, right? And specific heat. Yeah. That should be the thing. That should be the thing. ठीक है. So combine करके क्या हो जाएगा? It's just 2000. So 2000 joule per Kelvin, right? ओके, और टेम्परेचर कितने से कितना हो गया? 5 डिग्री से गिरा है. ओके, इन 1 मिनट, राइट? सो 5 डिग्री टाइम्स दिस मच, दैट्स गोना बी जस्ट 10 पावर 4 joules, and that's in 1 minute. 1 minute is just 60 seconds. So this is the thing, right? Yeah. So कितने watts? It's going to be 10 power 3 upon, okay, 10 upon 6 is 1.66 whatever, 1.67, and then ये तो गया 10 power 2. These many watts, of course. Or you could write like this thing. So it's like 1.67. Okay, that's not here, unfortunately. What? But why? Rate of cooling. कुछ भी गड़बड़ हो गई इसमें, नहीं? Yeah, those are kgs and everything. Of course, of course. It's 900 times 0.2. It's supposed to be 180. Yeah, that is 1200 ऑफ कोर्स बिकॉज 120 मिनट। हाँ ठीक है ना। सो कंबाइन करके क्या हो जाएगा? हाँ भाई 180 है। आह, गलत किया मैंने। It's not this thing. It's actually just, you know, 1380. ये गलत हुआ था मेरा. Fine. And this time's 5, of course. So, yeah, right. 65 and you got 40, which is 6900. And that upon 60, right? Yeah. If that should be it. Of course, ये गया. It's just going to be 1 और फिर यहाँ पे 1 और फिर 30 के लिए 5. So 115 watts, which is C option. Next question. 38. मैं काफी slow कर रहा हूँ. I know. 38. 2-liter water kept in kettle is heated by 1 kilowatt power source. Kettle is open and it loses heat at the rate of something. The time taken for the temperature of kettle to change from 27 to 77. So कितना change हुआ? Delta T is just, wait, what? अच्छा, rate constant है. Cool. 2-liter water kept in a kettle is heated by 1 kilowatt power source. Okay. Power source दिया है, so लिख ही देते ना. So volume is just 2 liters. Power source का power कितना है? 1 kilowatt is 10 power 3. Kettle is open and it loses heat at a rate of something. So heat loss का rate कितना है? 160 joule per second. Okay. The time taken for the temperature of kettle to change from 27 to 77. Hey, yeah, okay. Heat loss का constant है and power जो दे रहा है वो भी constant है. So it's not that bad actually. It's just 50. Okay, cool. So एक्चुअल में जो कंप्लीट हीट लॉस का है वो कितना रहेगा? दिस इज द पावर इट हैज. व्हाट वाज द पावर ऑन स्क्रीन? सो 1000, राइट? या और अपन इंक्रीज कर रहे हैं. सो राइट, इट्स नॉट अ फंक्शन ऑफ टेम्परेचर. दैट शुड बी द थिंग. सो यू नो लाइक ओके 1000 माइनस 160 व्हिच इज लाइक 100 माइनस कितना, वो फर्क ही क्या पड़ रहा है इस चीज से? इट्स अप्रॉक्सिमेटली जस्ट 1000 अनलेस यहाँ पे कुछ भी गड़बड़ कर रहा है ना. Not that bad. सारे तो अलग अलग दिख रहे हैं मुझे. So it can be done. Approximately 1000. Okay. That times the time required, right? Okay. And what do you want actually? Time required, right? Exactly. So okay, ऐसा करो ना. Energy निकाल लो. So for energy, you will just want heat capacity times temperature. 2 liter is like cha. Okay. How many? Okay, 1 calorie per gram and 1 gram per centimeter cube. So 1 calorie per centimeter cube. How many centimeter cubes? This is 10 power 3 centimeter cubes. So 2000 gram, 2000 calories, sorry. So 2 times 10 power 3 calories, right? That's the energy. Sorry, calorie per Kelvin actually. Okay, so delta T times that thing. It's supposed to be 10 power 5 calorie, right? इतनी एनर्जी अपने को देनी है. And 1 calorie is like 4.2 joules. So sorry, yeah, 4.2 joules times 10 power 5, right? Not 42, it's 4.2, right? So 2 can, of course. And the energy upon the power is just 10 power 3 in SI units. So ये गया. This will be 2 over there. It's 4200, 420. Okay. Yeah, इतना अपने को टाइम रिक्वायर्ड लगेगा अब ऑलमोस्ट. क्या मुझे 160 वगैरह लेना चाहिए था? नहीं, जरूरत नहीं है. सो दिस थिंग अपॉन 60 इज लाइक 7, अराउंड 7 मिनट्स. सो डी इज द आंसर. ओके, मे बी बी भी आंसर हो सकता है बिकॉज यू नो इट्स एक्चुअली क्लोज टू दैट. आई हेट दिस. ओके, स्टॉप दैट. दिस इज लाइक 10 पावर 3 माइनस 160. ओके, हैप्पी, राइट? और ये कितना था? 10 पावर what was this thing? It was, it's like okay, this thing times 10 power 5, of course. Okay, that should be doing it. No more stuff going on. So it's like 4.2 times 10 power 2 upon 1 minus 16 upon 10 power, it's like 0.16 basically. Approximately 4.2 times. It can also 42 0 लिखी दो. So 420 upon this thing 1 minus 0.6. करिए इतना क्या जा रहा है? So like okay, 0.4, it's 9 minus 1 is just 8, so 0.84 I guess. Yeah, yeah, okay, that's like 4200. okay, दो और डाल दिए upon 84, it's gonna just 2 और ये हो जाएगा 500. So 500 seconds, and that thing upon third is gonna be some lot of minutes. ठीक है ना, कर लेते हैं. सो सॉरी नॉट 30, ओके, मतलब क्या 420 प्लस 80, वेट, ओके दैट्स वियर्ड, इट्स नॉट इवन 7, इट्स एक्चुअली मोर देन दैट. इतना बड़ा डिफरेंस होगा मुझे लगा नहीं था एक्चुअल में, बट इट्स वेरी स्मॉल इन कंपेरिजन. अच्छा, उतना भी छोटा नहीं है एक्चुअल में, राइट, इट्स नॉट दैट स्मॉल एक्चुअली. दैट इज, वेट शुड बी ओके कूल. सो क्या कितने, ये इतने सेकेंड्स है ना, ऑफ कोर्स, राइट, 60 टाइम्स व्हाट, 60 टाइम्स 8, so yeah 8 minutes 20 seconds, which is A. Next question. पर ये अजीब नहीं है, आई थॉट कि इतना बड़ा चेंज नहीं होगा इसमें, इतने ने गलत कर दिया कुछ ना कुछ. 39, a fixed amount of nitrogen gas is taken and it is subjected to pressure and temperature variation. The experiment is performed at high pressure as well as high temperatures. The result obtained are shown in the figure. The correct variation of PV upon RT with P will be exhibited by nitrogen gas 3 1 mole, okay, n equal to 1 whatever, and N2, okay, pressure and temperature variation, ठीक है, so P versus T. Right, this is, oh, it's like PV upon RT. Okay, this is different. Whatever. Volume constant, right? Or is it not? The experiment is performed at high pressure as well as high temperatures. The result obtained are shown in the figure. The correct variation of PV upon RT with P will be. It's nitrogen gas though. I mean, it should not change. High pressures as well as high temperatures. High temperatures, wait, high pressures, that means कि जिस वहाँ पे V minus B आएगा, right? Okay, interesting. As well as high temperature. Okay, so this is a, this is very weird. Curve 4, curve 3, curve 2. We want what is P upon RT, right? Nitrogen is not, oh God, it's almost 1, but change होता है, right? How do you know कैसे change होता होगा? At high pressure, it's approximately just P times V minus B, P molar, that is, that's equal to RT, right? Okay, so PV upon RT is just equal to, oh God, you want, what is this? P atoms? That's okay, pressure versus PV upon RT the anyway. Okay, so maybe you just need to figure out what V is. So V is just equal to P plus RT upon P, right? और इसको तुम चिपकाओ PV upon RT. So P times ये चीज, that's gonna be just PB upon RT and then plus, you know, P upon RT of this guy, which is actually just 1. Cool. It's actually doing it. So it's just 1 plus PB upon RT. The thing is, yeah, right. Okay, so wait, constant क्या है वैसे? Volume is the constant, right? Of course, volume is what's constant. So, and we want in terms of pressure, of course. You want in terms of pressure. Hey, it's not that hard actually. So you got temperature in terms of pressure, right? So T is just, yeah, RT basically. Just put that in there. So it's supposed to be PV upon P times of V minus P. Well, that's weird. It's actually a constant. Yeah. So at high pressure, it will just be a constant. It's just, of course, then only the first one can be the correct one. So D is the answer. Okay. Right. So that should be it. PV upon RT, that is really just V upon V minus D. So वो चीज एक्चुअली कांस्टेंट बिकॉज वॉल्यूम चेंज नहीं कर रहे अपन, राइट? एग्जैक्टली. वेट, अपन ऐसा कभी बोला कि अपन वॉल्यूम चेंज नहीं कर रहे? अभी अपन चेंज कर रहे हैं, हु नोज. कंप्लीट इन ऑफ प्रेशर नहीं लिख सकता हूँ ना मैं. इन ऑफ वॉल्यूम अपन लिख सकते हैं, बट नॉट इन ऑफ प्रेशर. हाउ डू यू राइट ऑफ प्रेशर? यू कांट, बिकॉज उसमें आरटी वाली टर्म आएगी और कुछ है नहीं. You want to eliminate V or something? Whatever, next question. Time नहीं अपने पास में. Next. 40. 40 is a volume V absolute, okay, volume V versus absolute temperature diagram was obtained when a gas was heated in a constant pressure during the heating process from state 1 to state 2. 1 to 2 जा रहा है, volume versus temperature दिया है. क्या करना है अपने को? Mass. What is that? Okay, remain constant. गैस को हीट कर रहे हैं एंड गोइंग फ्रॉम देयर टू देयर, मास का क्या कर? ओके सो इट्स एन आइडियल गैस और व्हाट? अ गैस, नॉट एन आइडियल गैस, but assume the ideal gas है. So then P equal to nRT, right? Constant pressure बोल रहे हो, so V is proportional to, right, temperature, of course. जो slope रहेगा, that's indicating what n is, so mass does remain constant. Yeah, it remains constant. Next question, 41. 41 is the variation of density of water with temperature is represented by the curve in, okay, density of water with temperature is represented by the curve in, okay. Oh yeah, what was the thing once again? At 4 degrees, right? So usually क्या होता है, तुम फ्रीज करते हो तो तुम्हारी वॉल्यूम मतलब डिक्रीज होती है, बट इस केस में तुम जब फ्रीज करोगे तो 0 तक तुम्हारी वॉल्यूम डिक्रीज हो रही है, बट देन आफ्टर दैट एक्चुअली इंक्रीजेस और समथिंग. वेट, व्हाट वाज द थिंग? राइट, जो भी ज्यादा कोल्ड है वो नीचे गिर जाता है, सो एक्चुअली में वो वॉल्यूम छोटी रहती है. 0 डिग्री सेल्सियस वाला जो आइस है दैट्स एक्चुअली लाइटर देन वाटर. सो right, at 0 degree Celsius you got a minimum density, और फिर 4 तक you will have a maximum density, right? Because मैं कुछ तो भी गड़बड़ तो नहीं कर रहा इसमें. Density versus temperature, 4 degree Celsius. 4 का कुछ ना कुछ इंपॉर्टेंस था, क्या था? आई थिंक इट वॉज द पॉइंट after which density increase होना शुरू हो जाती है, right? So 4 was the minimum or something. This is definitely not correct. E is not right. और E क्या है? So density is still decreasing, you are saying, as temperature decreases? No. और इससे भी टेम्परेचर डिक्रीज होते हुए डेंसिटी डिक्रीज हो रही है, बट दैट डजंट मेक एनी सेंस. एंड ओवर हियर डेंसिटी इज इंक्रीजिंग. नो, दैट्स नॉट राइट. और इसमें क्या हो रहा है? So this point is 4 degrees Celsius where density is pretty low. और उसके बाद जैसे तुम टेम्परेचर डिक्रीज कर रहे हो, सो अच्छा उससे भी कम कर रहे हो. गॉड, ये अजीब हो रहा है. हाई टेम्परेचर पे तुम्हारी डेंसिटी काफी बड़ी है, देन तुम्हारी डेंसिटी डिक्रीज हो रही है. आई गेट दैट इट्स डिक्रीजिंग, बट देन उसके अंदर डेंसिटी इंक्रीज होना शुरू हो जाती है. आई डोंट गेट दैट. ओके, ये अजीब है और मुझे पता भी नहीं है. सो 42 मतलब पता है बट मैं भूल गया ऐसा बोल सकते हैं. Two different axiomal curves representing the relationship between volume V and pressure P for ideal gases shown are shown for absolute temperatures T1, T2. Then T versus P दिया है. T equal to constant, T equal proportional to temperature, right? T is so of course T2 is bigger than T1 and it's ideal curve. Ideal gas है ये, yeah, okay, right. And moles हमारे change हुए क्या? नहीं. So T2 is bigger than T1, which is this option. Next question, 43. 43 is the system changes from the state P1 V1 and P2 V2 as shown in the figure. What is the work done by system? So P1 V1 से P2 V2. The work done by system is, अच्छा P1 क्या है? And this is what? This is a, I think it's Newton per meter square. Is that the thing? I don't know. Whatever. और this is volume in meter cube होना चाहिए जो भी है. So ऐसा यूनिट्स ऐसा बोल रहे हो basically. So P1 is just 10 power 5. Okay, that's 1 atmosphere. And what's the volume? V1 is 1 meter cube. Okay. P2 is what? 5 times 10 power 5. इसको atmosphere में लिख दो. नहीं, जान दो. So 5 times 10 power 5. Right? Yeah. And what is V2? So V2 is 5. Cool. So क्या कर रहे अपन? What is the work done by the system? It's from P1 V1 to, so look, P1 up times V1, that's not remaining constant. P1 times P1 upon V1 is actually constant. Not nice. We just want like integration of PdV, right? So work done by the system, that's the thing. So yeah, okay, P is proportional to V basically, right? So P is basically like P1 upon V1 times V, right? That times dV, because तुम देख सकते हो ऐसा हो रहा है, it's a line and whatever. So yeah, it's just going to be P1 upon V1 and then इसका integration करो, so like V squared upon 2 it goes from, so 1 upon 2 and then V square goes from, you know, V2 square minus V1 square. That should be the thing. right? And this upon V1. ठीक है ना? That is the thing actually. That's the work done. Just do the thing. So 1 upon 2 times what is P1? Just 10 power 5. And then ये चीज कर जाएगी. So V2 square is 25 minus 1 and this thing is 1 as well. ऐसा यूनिट है सब कुछ. Should give us joules basically, right? 24.2 is just 12 times 10 power 5. That should be doing the thing. But that is just a C. Next question. 44. 44th is 1 mole of ideal gas undergoes a cyclic change as shown. The process AB is isothermal. The pressure and volume at point C is this thing. Okay, so and 24 is okay. C का क्या है? C, what's the pressure and what's the volume? The pressure is 1 atmosphere and the volume is 22.4 liters. I don't like that. Okay. Hey, that just means कि जो moles रहेंगे that is just equal to 1 basically, right? So C का आपने को बोल दिया, right? The temperature of gas at C is, oh wait, अच्छा temperature हम लोगों ने दिया नहीं, right? So okay, that's how it should be. Ideal gas है, cyclic process, AB is isothermal. AP is isothermal, so it went from ये स्टेट से पहले इस स्टेट पे गया, you got 2P, तो तुम्हारा जो टेम्परेचर लेट्स से इज T नॉट. ओके, सो C से कहाँ पे जा रहा है पहले ये और ये क्या है, इसको मैं P1 बोल देता हूँ लाइक, ठीक है ना? P1 is just equal to 1 atmosphere and V1 is equal to 22.4 liters. ठीक है, so it's P1 V1 that is at C. फिर क्या हो रहा है, फिर A पे it's 2P1 और टेम्परेचर का कुछ बोला नहीं, अच्छा वॉल्यूम कांस्टेंट है, राइट? सो या इट इज गोइंग टू बी द सेम स्टफ. P1, so temperature will just be 2T naught. Okay, and at what, at B, so isothermal is the same temperature, just going to be 2T naught, right? Of course. And right, okay, and what are the volumes or whatever, right? Pressure तुम्हारा कितना है, P1 दिया है, so it's going to be 2 V1 because A times C is equal to A times C. Makes sense? Okay, right. And now what? It's gonna go back और फिर इस पे आ जाएगा. Get it? ठीक है, अपने करना क्या exactly? We want to figure out what. Okay, we want to figure out what this thing is, right? This is very weird. Temperature of gas at C is what is T naught? But ये तो सही नहीं है. Oh, it's 1. Oh, come on, seriously. तुम्हें ये सब करने की जरूरत ही नहीं थी. Just had to be on NRT. I really thought इसमें कुछ तो भी information है. पूरा घटिया ये. All you need to know is P, V, and N. N is what? 1 moles, right? Yeah, just put the thing and yeah. फिर तो सही है ना. Temperature is room temperature. It's going to be 27 degrees Celsius or something like that. So B is the thing. Next question. Sorry, D. D is the thing. पता नहीं मैंने फालतू में पूरा डायग्राम क्यों ड्रॉ किया. 45th. 45th is the work in an ideal monatomic gas along the cyclic path. LMNO is, so LMNO इसमें work done चाहिए अपने को in ideal monatomic gas, whatever. So you know इसका जो area आएगा वो, which is क्योंकि इसमें वॉल्यूम पहले एक्सपांड हो रही है, राइट? उसमें तुम बड़ा वर्क कर रहे हो, तुम छोटा वर्क नेगेटिव छोटा वर्क कर रहे हो, whatever. कितना वर्क है? A just P times V. Yeah. So A is the answer. Next question. 46th. 46th is the curve which represents an adiabatic change. Is adiabatic change, so like V power gamma equal to constant. It's somewhat like a hyperbola but alag, काफी अलग, right? So I think C would be the thing. Linear तो हो नहीं सकता. Doesn't make any sense. What if PV is constant? Nah. Gamma cannot be 1. That doesn't make any sense. Because 1 से बड़ा होना ही चाहिए. CV it should be, ठीक है वो अपन देख लेंगे. So can it be T? What is D? No. C I think, और कोई तरीका नहीं. Although ये अजीब है क्योंकि वॉल्यूम इक्वल टू 0 पे प्रेशर कुछ तो भी है. How can that be? But whatever. In the diagram 1 to 4, variation of volume with changing pressure is shown. किसमें कुछ सच में यानी कोई और ऑप्शन है नहीं. So C is the thing. Come on, that doesn't look good. अगर ये asymptotes होते हैं, that would have made perfect sense. But ये नहीं है ना, तुम्हें दिख रहा है यहाँ पे इंटरसेक्ट कर रहा है ये. ठीक है, फर्क नहीं पड़ रहा. In the diagram 1 to 4, variation of volume with changing pressure is shown. A gas is taken along the path ABC. The change in internal energy of the gas will be. along the path what? ABCD. ABCD. Acha. And want to change in internal energy of the gas. So it's volume versus pressure. ठीक है ना जो भी है. हाँ ठीक है. What's the big deal? So positive. Okay. ठीक है. टेम्परेचर कैसे चेंज हो रहा है बस उतना देख लो. So यहाँ पे क्या हो रहा है तुम्हारा वॉल्यूम इंक्रीज हो गया A to D में, राइट? बिकॉज इन द एंड क्या हो रहा है वो ABC वो भूल जा सकते. A to D जा रहा है इंटरनल एनर्जी, राइट? स्टेट फंक्शन. A to D में क्या हो रहा है तुम्हारा टेम्परेचर इंक्रीज हो गया बिकॉज वॉल्यूम. सो वन में पॉजिटिव है. सेकंड में क्या हो रहा है? सो A to D, A यहाँ पर एंड D इज ओवर हियर. वंस अगेन वॉल्यूम इज इंक्रीजिंग एंड प्रेशर आई डोंट नो. वेट कहाँ पर है वैसे ABCD? आई थिंक दिस पॉइंट इज एंड दिस. हाँ फिर क्या वॉल्यूम इंक्रीज हुई प्रेशर भी सेम है सो इट इंक्रीजेस. एंड देन A to D वंस अगेन वॉल्यूम इंक्रीज हो गई प्रेशर. हाँ ठीक है ना. वंस अगेन द सेम स्टफ. A to D volume increases and pressure also increases, so of course it's gonna increase. और इस केस में भी एक्चुअली में शायद हो सकता है कि प्रेशर इंक्रीज हुआ हो. आई डोंट नो कि एग्जैक्टली ABCD कहाँ पर है. whatever, so it's positive in all cases. Zero, no. Zero in case 4. What? No, that's not right. Okay, maybe like second में zero हो सकता है, I don't know, but doesn't feel like that. The change in internal energy of the gas, it's along the path ABCD. Wait, तुम वापस A पे तो नहीं आ रहे हो? If you are actually coming back to A, then it's zero in all four cases. Because वो वाले ऑप्शन है ही नहीं कि तुम्हें D पे पॉजिटिव. Oh God, तुम्हें सही से बताना चाहिए ना कि ABCD A एक्चुअल पाथ है. But whatever, zero in that case. 48. 48 is carbon monoxide is carried around a closed cycle ABC. ABC, okay, in which species as thermal process is shown in the figure. The gas absorbs this much of heat. Temperature increases from 300 to 1000 Kelvin. क्या B to C I guess. Okay. B to C नहीं, वो तो change temperature zero है. In going from A to B. अच्छा A पे कितना है 300 and it's at 1000 over there. Cool. The quantity of heat ejected by the gas during the process CA is. So CA में कितनी क्या heat ejected? Fine. 700 joules of heat as its temperature increases from 300 to 1000. Okay, and it's at what constant volume? So you know you can figure out CV delta T and whatever. इसमें temperature हाँ ठीक है ना, इसमें energy का change zero है. This whole process is at constant pressure, right? Oh shit, इसमें work done होगा. Quantity of heat ejected. Oh, that is the change in enthalpy, right? So we just want Cp delta T. Cool. Right, it can't be that hard. So, come on, I can't even see what's going on. Pressure को तुमने change में दिया नहीं है, बस तुमने temperature का दिया ना. That's enough for me. Temperature 300 से कितना 1000 तक change हुआ, so delta U is ठीक है. I get it. That's 1000. It's like 1000 to 300 जा रहे हो. No big deal. We just want delta H. That's our heat, right? So it's just NCP delta T. That's equal to our Q. Yeah, मतलब heat absorbed of course. We want the heat release, तो उसका mod ले लेंगे, चिल negative ले लेंगे, whatever. What is the thing? It's just N कितना है? तुमने बताया नहीं. But why? Okay. That's weird. अच्छा ये जो प्रोसेस है it's at constant volume, right? So इसमें work done zero होगा, yeah. So internal energy का change is actually the heat. और कितनी heat है? 7,000 joules. So 7,000 joules is actually what delta U is, which is 1 gamma times of that. That's the thing. So gamma times temperature change same है. So yeah, gamma times delta U is delta H or negative or whatever. And what is gamma? It's carbon monoxide, right? So that's okay. So it's diatomic and like okay, ठीक है. कितने degrees of freedom हो गए? 5, I guess. राइट, 2 रोटेशनल 3 ट्रांसलेशनल. वाइब्रेशनल क्या है कुछ अपने को करना है? आई डोंट थिंक सो. सो 5 इज द थिंग. सो यू नो 5 yeah, like 5 plus 2.5, 7/5, right? 7/5 times 700 joules. That's the thing. So कितना हो जाएगा 4900 अपॉन 5 विच इज 49 टाइम्स 20 जूल्स दैट इज 980 joules. Isn't that the thing? Right, it's 7,000, sorry, not 700. एक एक्स्ट्रा जीरो चाहिए मुझे. 9800 joules, which is D. Next question. 49. 49. There are three thermometers, one in contact with the skin of the man, कौन सा? Other in between the vest and shirt, and third in between the shirt and coat. Okay, thermometers है तीन. One in contact with skin of man. Oh God, seriously, इसको मैं thermometers का नाम दे देता हूँ ABC. Okay, contact. एक स्किन में है. ओके, अदर बिटवीन द वेस्ट एंड शर्ट. व्हाट इज द वेस्ट? ओके ओके ओके, फॉर बिटवीन द शर्ट एंड कोट. सो वेस्ट टू शर्ट का जो रीजन है उसमें है. एंड लास्ट जो है शर्ट शिफ्ट भी लिखा मैंने इसमें, शर्ट टू कोट का जो रीजन है उसमें. राइट, सो एक स्किन. राइट, ओके, कैसा है कि तुम्हारी या ये उसकी स्किन है, यहाँ पे शर्ट की लेयर है और ये कोट है. राइट, सो तुमने ए को है यहाँ पे रखा हुआ है. ओके, ए इस पे टच कर रहा है. बी इज नॉट टचिंग द वेस्ट, इज एक्चुअली टचिंग दिस थिंग. राइट, यहाँ पे जो एयर है ऑफ कोर्स goes between vest and shirt. Okay, and this is shirt and coat, so that's C. Right, उसके बीच में. If vest and shirt are of same thickness. Oh, okay, it's kind of weird. But बीच में जो हवा है उसका तुम क्या करोगे? Thermal conductivities. Okay, assume वो एयर की लेयर है ही नहीं. So it's just कि ये जो पूरी राइट ये जो शर्ट है उसकी जो थिकनेस है वो काफी बड़ी है. सो एक्चुअल में ये बेसिकली तुम शर्ट पर है यही अज्यूम कर सकते हो. राइट, ओह गॉड, दिस इज वेरी वियर्ड. एक स्किन के बीच में. अच्छा, तो ये पूरा जो है ना जस्ट शर्ट एंड दिस थिंग इज द कोट. राइट, वो लेयर्स ऐसी है इसकी. यहाँ पे तुमने बी रखा हुआ, यहाँ पे सी. आई गेट इट. If the reading of thermometers are 30 degrees, 25 degrees, 22 degrees Celsius respectively, A, B, C, D. Okay, if the vest and shirt are of the same weight. Okay, if the vest and shirt are of the same thickness, so same thickness, cool. The ratio of the thermal conductivity is, I mean, what the hell? This delta H, that's proportional to temperature difference, of course. Delta H is proportional to temperature difference, of course, times the conductivity. So इन दोनों केसेस में सेम हो रहा है. So K delta T is the same. तो K vest क्योंकि yeah, okay, K shirt or whatever. This shirt same thickness. Wait, something's weird about this. Shirt and coat. Wait, what is a vest though? Is it something kind of undergarment? No, I don't think so. What is this thing? ये शर्ट की लेयर नहीं है क्या? वन इन स्किन, एक जो है वो स्किन के कांटेक्ट में, एक वेस्ट और शर्ट, और तीसरा बिटवीन शर्ट एंड. अच्छा, तो एक और लेयर है. सो ये वेस्ट है एक्चुअल में. दिस थिंग इज द शर्ट एंड दिस थिंग इज द कोट. राइट. Reading of thermometer are 30 degree, 25 degree, and 20 degrees Celsius, whatever. If the vest and shirt are of the same thickness, so you know same thickness के, cool. Right, and area भी same ही है. Ratio of their thermal conductivity is, so ठीक है ना, K vest times इसका delta T कितना है? So 30 to 25 times 5, of course, that's equal to K shirt times delta T इसके लिए कितना है? 3. Right, so kb upon ks, that is equal to k upon 5. That's what we want. 3 to 5. Okay, D is the answer. Next question. 50. 50 is heat is flowing through two cylindrical rods of the same material. The diameters of the rod are in the ratio 1:2 and lengths are, okay, so rods क्या A और B बोल देते हैं. Diameters में भी radii basically कुछ इस ratio में. Right, so radii are in the ratio 1:2. Okay, lengths are in the ratio 2:1. Okay, if the temperature difference between the ends be the same, so delta T 1:1. Okay, same material, so K is also 1:1. Cool. The ratio of flow of heat. अच्छा तो अपने को H का I mean come on seriously, it's like Ka upon L delta T, right? Or area is like, okay, we can figure out area. Area is 1:4 ratio में, तो फिर जो heat flow है just like area upon length है ना, so 1/2 is to 4/1, right? Which is 1:8. So that's the heat flow rate, which is B. Next question. 51. 51 is a block of steel heated to 100 degrees Celsius is left in a room to cool. जो following curves shown in the figure represents the correct behavior. Convection है कि नहीं इसमें? तो फर्क क्या पड़ता है? Temperature versus time, हाँ. Correct behavior. This is kind of weird. अगर convection currents है, then it's a block of steel left in room to heat. I guess radiation अपने को इसमें use करना है सिर्फ, but that's kind of not true because convection रहेगा इसमें, right? तो उसका अपन क्या करें? मैंने कभी कन्वेक्शन कैसे काम करता है पढ़ा नहीं है, सो दिस इज नॉट गुड. कम ऑन, दिस इज नॉट गुड एट ऑल. बट स्टिल अगर अपन सिर्फ रेडिएशन के थ्रू देखें देन इट्स लाइक सिग्मा T पावर 4. दैट्स द राइट. ओके, सो यू नो negative dt upon t small t time basically, that is proportional to T power 4, right? So you can kind of say that T4 dt is equal to k times dt basically. इसको integrate कर दो, so it's like -4 something like that. 4 T power negative, oh we want to integrate, sorry, divide to -3 so 1/3 and then you got T power -3, so 1/3 और क्या ठीक है ना, कॉन्स्टेंट में आ ही जाएगा whatever, and then like 1/T power 3 minus जो भी इनिशियल था 1/T naught power 3, that is equal to k times t, right? Okay, so 1/T cube is something like mt plus c, you can say. That's time, this is right, so 1/, मतलब क्या, t cube is equal to 1/mt plus c, some kind of linear function, and then your time. Cool. So अगर suppose ये c 0 होता और m भी 1 होता, then it's like 1/T, so right, t capital T, which is p t to the power -1/3, which is right, it's reaching an asymptote when t approaches infinity, or you know, in this case some kind of value, right? It should go to an asymptote at some finite value, right? So I guess A might be the thing, but who knows, because actual में ऐसा scenario होता नहीं है कि सिर्फ radiation से हो रहा हो. Whatever. Next. 52. The following figure shows two air-filled bulbs connected by a U-tube partly filled with alcohol. What happens to the levels of alcohol in the limbs X and Y when the electric bulb is placed midway between the between the bulbs is lighted? What? अच्छा, ये जो दो बल्ब है उनके बीच में तुमने एक इलेक्ट्रिक बल्ब रखा है और उसको तुमने लाइट किया है. एयर फिल्ड है ये, ठीक है. Connected by U-tube partly filled with alcohol. Okay, understandable. Levels of alcohol को क्या होगा when you, right, so this is painted black, तो इसका टेम्परेचर जो होगा that's gonna increase faster because ये रेडिएट मतलब ये रिफ्लेक्ट कर देगा, so इसका टेम्परेचर इंक्रीज होगा. मतलब थ्रू कंडक्शन इसमें जो एयर है वो भी इंक्रीज हो जाएगी, उसकी हीट इंक्रीज होगी, इसका टेम्परेचर इंक्रीज होगा, राइट. राइट, कॉन्सेंट्रेटिक अज्यूम कर लेते हैं, सो इसका टेम्परेचर ऑलमोस्ट इसके सेम ही है, राइट. सो क्या मतलब वॉल्यूम ऑलमोस्ट सेम है, सो इसका लाइक प्रेशर इंक्रीज हो जाएगा. बिकॉज ऑफ द इंक्रीजिंग प्रेशर इट्स एक्चुअली गोइंग टू गो लाइक दिस, सो या राइट. सो आई गेस दैट यहाँ का जो अल्कोहल है वो ड्रॉप करेगा, यहाँ पे इंक्रीज होगा. लेवल ऑफ अल्कोहल इन लिम एक्स और वाई का, ये एक्स है कि ये एक्स है? हाउ डू यू इवन नो कौन सा एक्स? तुमने ना लेबल किया ना बताया कौन सा. सीरियसली, ठीक है, आई एम अज्यूमिंग दिस इज एक्स बिकॉज वो पहले है, जो भी है. फॉल्स फाइल दैट इन वाई rise. Yeah, there's no change of level of particles. Now it should be A, I think. Next question. 53. Heating this make this expand, or pressure increase हो रहा है, and it's gonna happen like that. Okay, next. A heat flux of 400 joule. ठीक है, H कितना है? 4,000. Sorry, 4 times 10 power 3 is passed through a copper rod of length 10 centimeter. Length is equal to 10 power negative 1, and area of cross section uh come on, centimeter square. Seriously, like 10 power कितना? negative 4 हो जाएगा ये. 10 power negative 2 basically. Okay, the thermal conductivity is 400 cool. The two ends of the rod must be kept a temperature difference of. ठीक है ना? No big deal. So H is equal to Ka upon L delta T. Delta T is just equal to HL upon Ka. Let's calculate this thing. H कितना है? इस in Kelvin Celsius फर्क नहीं पड़ रहा. Delta है ना? Okay, 4 times 10 power 3 times length is 10 power negative 1 upon K कितना है? 400 times A, which is 10 power negative 2. तो ये तो गया, right? ये भी गया. So it's 10 power 2. So 100 डिग्री सेल्सियस, और वो है नहीं इस आंसर में. वेट, ओके, ये कुछ और है. ये है ना, राइट, 100 डिग्री सेल्सियस, दैट्स सी. मैं 54th कर रखा था गलती से, अब करेक्टली करते हैं 54th. 54th is on a new scale of temperature which is linear and called the W scale. The freezing and boiling points of water are this and this. What will the temperature on the new scale corresponding to 39 degrees Celsius on the Celsius scale? Okay, right. So it's like, okay, what's this? 39 degree watt and 239 degree watt, right? No big deal, right? What will the temperature on the new scale corresponding to temperature of 39 degrees? तो फिर कितना, मतलब 0.39 times delta T बोल देते हैं, delta T is like the change in temperature in the W scale between boiling and freezing, right? तो उसका 0.39, yeah, and that thing plus जो freezing पे तुम्हारा temperature था, which is 39, that will be the thing. Makes sense. So 39 degree plus delta T is what? 200. Okay, so it's like 39 times 2, which is, okay, 39 times 2. This is random, I see. So basically 3 times of 39, which is like 9 and 27, just 217. So गड़बड़ कर रहा हूँ मैं. 9 and 27, that's 117. So D is the answer. Next. Oh, next you. कोई क्या नहीं. Fine. Let's check the questions. ये जानते चेक नहीं करते, उनके गलत रहते most of the time. So जो भी. So I'll see you guys in the next video. मैं क्या बोल रहा हूँ. I'll see you guys in the next video. Bye.